This is Mr. Parker. Nice job. You rock. Take these 10 points. Cha-ching. All right, students. Question 6. We skipped 5 because you were doing so dynamite. I said, you know what? Let's go and skip 5. Let's go look at 6 right quick. Which statement about the fractions 2/10 and 3/15 is true? All right. First thing we're gonna do is circle the important numbers 2/10 and 3/15. We want to find out which statement is true. So we're gonna really have to understand fractions very well, or at least understand what we know about them. So the first thing I want to do, if I want to find out what statement about two fractions are true, let me go ahead and compare these two fractions to see what I know about them. All right, sorry, my handy dandy red pen been acting up. All right, so we have 2/10 and 3/15. All right, 15. So we're going to compare them. And we're going to compare these fractions using oops. Let me go ahead and fix this right quick. All right. All right, we're going to fix it now. 3/15. We're going to compare these two fractions using cross multiplication, a very simple method, or the butterfly effect, depending on what you choose to call it. All right, so we're going to do 2 and 15, and cross them. 2 are going to be multiplied. And 10 and 3. And we're trying to see what we know about these fractions by comparing them. All right, so 2 times 15 is going to give us what? 30, correct? Good job. All right, so now we're going to go and cross 10 times 3. 10 times 3 is going to be 30 as well. So what do you notice right off bat about these two fractions? Yep, they are equivalent. That means they're equal. They're the same. So we have that information. Now let's go into the answer choices and see what makes sense. These fractions are both greater than 1 because their denominators are greater than their numerators. Just because of a denominator is greater than its numerator, does that mean that it's going to be greater than 1? No, it's going to be a fraction. In order for a fraction to be 1 or greater than 1, it must be what? The numerator must be the same as its denominator or greater. So we know off bat that question A is not right. All right, so let's look at question B. These fractions are equivalent because their numerators are 5 times their denominators. Well, looking at right now, we know that 2 is not 5 times larger than 10. So B cannot be right. Then it says C. These fractions are both less than 1 because their numerators are greater than their denominator. 10, let's try 10 over 2. 10 over 2 would be an improper fraction because they're saying the numerator is bigger than the denominator. And anytime that happens, we know that the number is going to be what? Greater than 1. So it's saying it's less than 1 if it was 10 over 2. And that's not even our numbers we're dealing with. So we know C is not right. Now D, these fractions are equivalent because their denominators are 5 times their numerators. Now let's try it. 2 times 5 is 10. So let's try on 3. 3 times 5 is 15. Let me do it. 3 times 5 is 15. So would you agree that the denominator is 5 times larger than the numerator? Yes, so the answer should be D. Good job. Oh no! Don't panic. Let's do this together. I'm here to help you review. This is Mr. Parker. Nice job. You rock. Take these 10 points. Cha-ching. All right, students, we are on question 7. It says shade the portion of the figure represent a fraction. Which model is not equivalent to this fraction? All right. First thing we want to do, we don't have any numbers to circle, but we're going to actually circle this fraction because this is the fraction that we're looking at. And beside it, and we're going to underline our question, which model is not equivalent to this fraction? All right, so let's go ahead first and label this fraction. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 total pieces. That's going to be our denominator. Fraction bar. Now, how many are shaded? We have 1, 2, 3, 4, 5, 6. So we're going to put 6 on top. This is our fraction that we're looking at. All right, now we're trying to find out, first of all, what are we looking for? We're going to go and label all the other ones. So we're going to label this just to give us what? 6, because we have 6 total parts. Good job. And how many are shaded in? 3. 1, 2, 3. Go ahead. We have 3. That's 3 over 6. But wait, did we forget something? We did. It says which model is not equivalent to this fraction. That's the key word, not. So let's find out about 6, 8, and 3, 6. But let's label the rest of them with. So we have 8 total parts. How many are shaded? We have 2, 4, 6. So 6 eighths. We know already 6 eighths is equivalent to 6 eighths. So we know B cannot be what? The correct answer. Now let's look at C. We have 4 parts, total parts, and we have 3 that are shaded. 3/4. So now we can X out B because we know 6 eighths is equivalent to 6 eighths, but let's go and try 3 6 and 6 eighths. Let's see if they're equivalent. And we're going to use cross multiplication. All right. First, we're going to go ahead and do 3 times 8. And then 6 times 6. So let's see if they're equivalent. All right. So we know 3 times 8 is 24. That is correct. Put a little circle over there. And 6 times 6 is 36. All right, good job. So we know right now that what? These fractions are not equivalent. And therefore our answer is A. Good job. Oh no, don't panic. Let's do this together. I'm here to help you review. This is Mr. Parker. Nice job. You rock. Take these 10 points. Cha-ching. All right. Apple pie was chosen as the favorite flavor of pie by 8 of 32 students in Ms. Delco's class. Which model can be used to find a fraction equivalent to the number of students who did not choose apple pie as their favorite flavor of pie? Now, we're going to go through this fairly quickly. First thing we need to notice is that we're dealing with 8 people who chose apple pie. So we're going to circle 8. And we have a total of 32 students in all. All right, we have 32. So now, Delco's class, which method? Okay, so we're trying to find which method can be used to find a fraction equivalent to the number of students who did not choose apple pie as their favorite flavor of pie. Oh no, don't panic. Let's do this together. I'm here to help you review. This is Mr. Parker. Nice job. You rock. Take these 10 points. Cha-ching. All right, so number 9. Jayla baked 2 identical chocolate cakes for the school bake sale. She cut one cake into 9 pieces, another cake into 18 pieces. The models are shaded to represent the fraction of each cake that was sold at the school bake sale. Which statement correctly compares the fraction of each cake that was sold? So, first thing we want to do is we want to go ahead and circle our important numbers. We have 9. Then we have 18 pieces. The models are shaded to represent fractions. So they want to know which statement correctly compares the fractions of each cake that was sold. So first thing we want to do is go in and label our fraction. So let's label the first one. Or the fractions, the 2 identical. That's very important because we know we can't compare anything unless it is the same size. So these are two identical pieces of cakes. So she cut one cake into 9 pieces and the other into 18. The models are shaded, so we know we're looking for the shaded portion to help us. I'm going to represent our numerator. And represent means it's going to be. All right, so first thing we want to do is look at our two models. Our first model will equal, and our second model will equal. We're going to find out what the fractions are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 total parts. So that means that's going to be our denominator. Then how many do we have shaded? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 over 18. So now we're going to look at our second cake, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So our total parts are going to be 9, and the shaded portion will be 1, 2, 3, 4, 5. So that's 5 ninths. So right now we're going to be looking for the answer choice that shows these two correctly. These two models correctly represented. And we're going to do this by creating to see if they're greater than, less than, or equal to. So we have 9/18, and now we're going to put our 5 ninths and 9/18. All right, so now we're going to do cross multiplication. 9 times 9 and 18 times 5. Now I want you to stop and do this yourself and tell me what you got as your answer. And you should be able to go back and find out what you did wrong. All right, so I will see you on the next problem. Oh no, don't panic. Let's do this together. I'm here to help you review. This is Mr. Parker. Nice job. You rock. Take these 10 points. Cha-ching. Gabrielle talked on her cell phone to 2 family members. She talked to Auntie Mendez for an hour, 3/4 of an hour, and Cousin Sue for 6/9 of an hour. Which family member did she talk to the longest? All right, so we know right now we have 2 fractions. We have 3/4 of an hour, and we're looking at what, 6/9 of an hour. So we're gonna do, and there's 2 family members. We're trying to find out which one did she talk to the longest. So we have 3/4, and we have 6/9. All right, now, in order to find out which one she talked to the longest, what you will want to do is we need to compare the 2 fractions. We have 6/9 and 3/4. So we're going to do 3/4. We're going to compare it to 6/9. So we're going to use cross multiplication. I want you to go and try this yourself for a second and see what you got. And then I want you to, if you go back and find out what you did wrong. All right, so we know that 3 times 9 is going to give us 27, correct? And 4 times 6 is going to give us 24. So 4 times 6 is 24. 3 times 9 is 27. So therefore, 3/4 is greater than 6/9. So our answer should have been 3/4 is greater than 6/9. Good job. Thank you for working this out with me. I will see you again soon. Nice job. You rock. Take these 10 points. Cha-ching.